Okay, guys, welcome to our next section. We are talking about functions and relations today, and I think this sounds maybe a little scarier than it actually is. So, hopefully, you have your guided notes ready to go. And this top box is just going to be all of our vocab that we need for this lesson and for the rest of the chapter. We're going to be referring to this a lot. So the first thing is what a relation is, and it's represented by a set of ordered pairs. And we've been seeing ordered pairs with our graphs before, so these are not new. So it's kind of just like a list of numbers. And remember, ordered pairs go in the order x, y. So all your x values come first, then your y values. The domain, okay, when you're asked for the domain, it's the set of all the x values. And the range is all the y values. So all these things that we've just talked about, relations, domain, and range, is kind of just a list of numbers, okay? Another name we have here is the independent variable, and that's the same thing as the x values, and it's also called the input. So it's the stuff that goes into our function. And then the dependent are the y values, and those are output. Okay. Now, a special type of relation is called a function. And something is a function if for every x value, there is exactly one y value. So every x is matched with just one y value. And then the last thing is that each value in the domain of a function is called an element. And same thing for range. Okay, so these are just our vocab words, and I'm going to show you what they actually look like as we go through our notes. Okay, so in examples 1 and 2, it says identify the domain and range of each relation. So again, a relation is just a bunch of ordered pairs. Domain is going to be our x values, and range is going to be y. So for number 1, we have 4 ordered pairs listed for us. And remember, it goes x, y for ordered pairs. So domain, all we have to do is list all the x values. So my domain would be -2, 0, 4, and -2. And my range is all my y values, 0, 3, -7, and -1. And that's all it is. It's just a list of numbers. So in example 2, all that's different is instead of listing as ordered pairs, we've made a table. So my ordered pairs are now in these columns. And my domain, again, are just going to be my x values. So looking across for x's, my domain will be -4, -1, 2, and 3. And my range, going across the bottom, all my y values, 1, -5, 8, and 1. So I always remember domain and range because just like x and y are alphabetical, domain and range are alphabetical. So domain paired with x, range with y. So now in 3, 4, and 5, it says determine whether the relation is a function. And look back at your vocab list here. A relation is a function if for each x value, there is exactly one y value. So you're looking for repeats of x values. Okay. So I'm just going to write every x has one y. So in example 3, I've got -5 with 0, 0 with 1, 0 with 4, and 3 with -7. And I notice that I have the x value 0 listed twice. So this is not a function because the x value of 0 is paired with both 1 and 4. So look at my ordered pairs that I've circled. 0 goes with 1 and 0 goes with 4. So it is not a function because my x value 0 has 2 y values. All right, looking at number 4, I've got, remember the table just goes up and down. So 2 with 1, 6 with 3, 1 with 8, negative 1 with 3. So yes, this is a function. Every x value only has 1 y value. And number 5, again, another table, goes straight down. Okay. And I notice I have the x value 3 listed twice. It's paired with 2 different values. So this is not a function. And again, because the x value 3 is paired with 0 and 1. So if your x value is repeated, okay, so I got 3's here or 0's here, then it's not a function. So another way to show our relations and functions is by graphing things. And we're going to be using graphs a lot moving forward. But when given a graph or a picture of a relation and asked if it's a function, we use something called the vertical line test. And the vertical line test says, or it helps you decide if a relation is a function by looking to see if any vertical line, so we're going up and down, vertical line drawn does not intersect with the graph at more than 1 point. So again, in other words, on the graph, each x value is paired with only 1 y value. And here's how the vertical line test works. If you're looking at number 6, and you can take a highlighter or your pencil, and what it's saying is if you draw a vertical line anywhere on your graph, if it only passes through 1 point, which it does on this one, right, then yes, it is a function. But if you draw a vertical line, let's make this a little straighter. If you draw a vertical line and you hit more than 1, like I just did, right? I've got a point here and a point here on the vertical line, then your answer is no, it is not a function. It does not pass the vertical line test. So for number 8, if you draw a vertical line anywhere you want, okay, look, I'm crossing through my graph at multiple points on each of these vertical lines. So number 8 is, again, not a function. And one more, number 9, draw a vertical line all over your graph. You're only ever intersecting with that squiggle once on every line. So this is, yes, it is a function. So all we have right now is deciding if something is if a relation is a function. We're looking to see if every x value only has 1 y value. And we can do this by looking at our list of ordered pairs or by a graph. And now, if you flip your notes, we also have what are called mapping diagrams and tables. And the same thing, same rules for all of these, just multiple representations. You're looking for each x value will only be paired with 1 y value. Okay. And this is important. A y value can be paired more than once, but an x value can't. So you're always kind of just looking for a repeated x. Okay. So in number 10 here, this is what we call a mapping diagram. And input, remember, is x, output is y. So these are my x values. And what the mapping diagram says is the value of 1 is matched with 0, 3 is matched with 6, -2 with 3, and 5 with -4. None of those x values are repeated. So yes, it is a function. If I look at number 11, I see right away the 3 is going in 2 directions. It's paired with -2 and with 3. So this is a no. It is not a function because 3 is paired with more than one number. Looking at 12, you're just following the diagrams. I don't have any repeated x values, so yes, this is a function. Same thing with our tables. Every time you do this, you're just looking for repeated x values. So I have -6 with 1, 3 with 8, 2 with 3, 7 with -2. We're good. That is a function. In number 14, I've got -2 with 3, 4 with 5, 8 with 9, and 4 is now again paired with 2, which means I've got a repeated x value, which means no, this one is not a function. And our last one, no repeated x values. So yes, we're good. If you are a little concerned because you saw the 3s twice on the y side, that's okay. Remember, y's can be repeated, x's cannot. Okay, so you're only worried about the x values when deciding if it's a function or not. More specifically, though, getting a little more detailed, we have what's called a one-to-one function, where every element of the range, remember our y's, of the function corresponds to exactly one element of the domain, okay? So if we have this equation, y equals f of x, and we'll talk about function notation in a class or two. If it passes the vertical line test and, vertical line test, we can say it's a function. It's a one-to-one function if it passes the vertical line test and the horizontal line test. So this is a little different, and I'll show you what this looks like. A one-to-one function can't have any repeats of x's or y's. So the first one we're looking at, we're deciding, is this a one-to-one function? So you're asking yourself, are there any x repeats? Are there any y repeats? And it looks like for the first one, we go 2 to 4, -8 and 0, 1 to 5, 3 to 1. So yes, this is a one-to-one function. Okay. On a graph, here's where we do the two tests. So I'm testing this line that I just marked in bold, and I'm first going to do the vertical line test. So if I draw a vertical line anywhere, I'm only crossing through that black line once. But now I also have to do the horizontal line test, where I draw horizontal lines. And again, I'm looking, does it cross that line, that black line, at more than one point on any of my horizontal lines? And it doesn't. So that's good. So yes, it is a one-to-one function. Looking at our tables, this one is good. It's another yes for a one-to-one. Number 19, we've got a repeated y value. So this is a function, but it is not a one-to-one function. On my next graph, it looks like I passed the vertical line test, which makes it a function, but when I go to do my horizontal line test, I'm crossing through that curved shape at multiple points. So this is no, it is not a one-to-one function. And last thing here, we've got some letters and Roman numerals. You can have anything for a relation. It's listed as an ordered pair, but remember, it's just a list of stuff. So notice that A is going to the Roman numeral 2, and so is C. That means this is used more than once, so no, it is not a function. Okay. So last thing you have to do is make a set of ordered pairs that represents a one-to-one function. So you should have no repeat x or y values. Okay. All right. So you have to make your list of ordered pairs for a one-to-one function. We're going to do some more practice with this, but things to review are your vocab, okay? And I've also included in your notes a summary chart with some notes on it for you. So it looks like this, but it has some notes on it. So make sure you look at that as you finish up your notes. And I will see you guys soon in class. Bring your questions to class, bring your notes, and I'll see you soon.